Hi, my name is Ishraq Mustafa, and today I'm going to be talking about slide bearings and lubrication. Now to begin, what is a lubricant? A lubricant classifies as any interposed substance that minimizes friction. Lubricants are generally liquid, but sometimes they may be a solid. One example of a solid lubricant would be graphite. Lubricants can also be a gas. One example would be pressured air. What are the types of lubricants? There are three different types of lubricants: liquid lubricants, solid lubricants, and gas lubricants. For liquid lubricants, the two most common types are oil lubricants and grease lubricants. We will get more in depth about each of the different liquid lubricants in the next slides. Oil lubricants. Oil lubricants are differentiated by their viscosity and other properties. Modern oil lubricants contain multiple additives usually. Some of these additives are pour point depressants, viscosity index improvers, defoamants, oxidation inhibitors, corrosion inhibitors, detergents and dispersants, and finally, anti-wear additives. Now here are grease lubricants. Grease lubricants are just thicker forms of liquid lubricants. They have been thickened to provide special properties. When you require a lubricant to stay in position, you would use grease. This is usually done when liquid lubrication may either be too costly or too difficult or both. Grease can also provide a cooling function and a cleaning function because it cannot circulate. What is a sliding bearing? A sliding bearing is a bearing that requires direct sliding of the load-carrying member on its support. It is used in applications such as the crankshaft bearings in an engine. They differ from rolling element bearings that have balls or rollers interposed between the sliding surfaces. Sliding bearings provide surfaces of an appropriate material. Some of these materials are babbitt or bronze. Sliding materials can be split or made into a bushing. Types of sliding bearings. There are two types of sliding bearings. They are called journal/sleeve bearings and thrust bearings. Journal bearings are usually to support radial loads. This type of bearing is cylindrical. Thrust bearings are generally used to support loads in the direction of the shaft axis. These bearings are usually flat. One common application for journal bearings are when they are used as the main bearings and camshaft bearings. One common application for thrust bearings are to support the axial loads that are caused by the helical gears in a vehicle transmission. Different types of lubrication. There are three types of lubrication. They are known as hydrodynamic lubrication, mixed film lubrication, and boundary lubrication. The first one is hydrodynamic lubrication. This is used when the surfaces are completely separated. Surface wear does not occur in this case. Typical film thickness at the thinnest point is 0.008 to 0.020 millimeters. Friction originates only within the lubricant film. The typical values for the coefficients of friction are 0.02 to 0.010. Mixed film lubrication is used when the surface peaks are intermittently in contact. The surface wear can be minimal with proper design. Coefficients range from 0.004 to 0.10. Boundary lubrication is used when surface contact is constant and extensive. However, the lubricant reduces surface wear and friction. The coefficients range from 0.05 to 0.20. Basic concepts of hydrodynamic concepts. Hydrodynamic lubrication is used commonly in vehicles. For example, hydrodynamic lubrication occurs within the engine. To be even more specific, the crankshaft, and the camshaft. Hydrodynamic lubrication is achieved when a surface, or in the case of the crankshaft, the shaft is rotating at its intended speed, and with the oil lubricant in place, the surfaces will make contact. When the rotating speed is increased, pressure gets built which prevents both surfaces to touch because it causes the crankshaft to float. In hydrodynamic lubrication, there are three factors that influence the coefficient of friction and the type of lubrication. They are known as viscosity, rotating speed, and bearing unit load. A higher viscosity results in a lower rotating speed required to make the journal flow. It also produces more bearing friction. A higher rotating speed means less required viscosity. It also produces more bearing friction. Bearing unit load is known as the load W divided by the bearing projected area, which is journal diameter d times bearing length L. A smaller load means a lower N value and lower viscosity value to achieve float. A reduction in bearing load increases the bearing coefficient of friction. To sum it all up, if you want to achieve hydrodynamic lubrication, you need relative motion of the surfaces, a wedging action, and presence of a suitable fluid. Thank you for listening to my presentation. I hope you learned something, and I hope you enjoyed. Take care.